Hi, you rates. So today what we'll be doing is investigating rates. So they're kind of similar to ratios, but there is one very distinct difference. So what I'll do in this video is kind of start talking you through the difference between the two. We'll have a look at them and then do some examples. Okay, so the first thing I want you to do is grab your notes and write in your heading. So your heading today is going to be exercise 6E, rates. All right, so you should have written the heading in. Now what we're going to do is just have a look at what a ratio is. We've been using them over the last couple of periods, but maybe you've forgotten or you can't remember exactly the definition, or you never really clicked with the definition in the first place. So what a ratio does, it shows the relationship between the values of the same type of quantity with the same units. Okay, now what does that mean? Well, again, remember the scenario we had that what Rosie and Jesse did was that they contributed some money to some sort of an investment, and they rated their piggy banks, if you remember. Rosie contributed $100 and Jesse contributed $300. Now remember, what we did was we wrote that as a ratio, and we're allowed to write that as a ratio because the reason is that it's the same quantity, all right? And the same quantity is the money, all right? So we've got quantities which are money. And it really importantly, it's the same unit. They're both in dollars, not one's in cents and one's in dollars. Okay, so recall we wrote that as 100 to 300 or just 1 to 3. All right, so that's what ratios are, same type of quantity with the same units. Now, what's the difference between that and a rate? Well, what a rate does is it shows the relationship between two different types of quantities with different units. So things are related that have different types of quantities and different types of units. Okay, so an example of this might be the growth rate of an adolescent boy. I don't know whether this is true or not, but it's suggested in the textbook that it's 12 centimeters per year, or 12 cm per 1 year. All right, that's a suggestion in the book. All right, so that would be the rate of growth. Okay, so again, rate of growth. Now the quantities in this case are time, okay, and height. All right, so that's it. So we're looking at time and height. All right, and the units that we measure time in, well, in this case, it's years. We could do months if we wanted. That would be a different rate, okay, growth rate per month. And we could, or we're using centimeters to measure height. We could measure kilometers or something like that, measure it in kilometers, but that would be a little bit weird, wouldn't it? Okay, so we're doing that. So again, recall that rates have different types of quantities with different units. Okay, and again, ratios, same type of quantity, same units. So for that reason, when we quote a rate, we don't quote this as a ratio. Okay, this is not a ratio. We say it as a rate, and that's how we say it, 12 centimeters per year. All right, imagine this scenario. You're driving in the car with mum, dad, or someone at home, older sister, older brother, and you ask how fast you're going. And the response is, I'm going 110 kilometers every 2 hours. And you might sort of go, well, that's a bit weird. Okay, so sounds strange, because when we state rates, it should say when we state rates, it's convention to write them in simplest form. Now, what does simplest form mean? It means writing the rate for only one unit of the second quantity. Okay, so this is the second quantity here, so we want it per 1 unit. All right, now an easy way to do that is you write down what you've got, the information here, and all you do is, just like we were doing with ratios, you simply turn this number into 1. All right, now how would you turn 2 hours into 1 hour? Well, you'd scale it by dividing by 2 or multiplying by half. So we're going to divide both of those quantities by 2, and we're going to get 55 kilometers in 1 hour. Okay, and then we can really say that as a rate because that's the speed of a car. That's how we read a speedometer. When we see the number of the speed that we're going, what that represents is how many kilometers per 1 hour you're expected to travel. Okay, so this one here, we would say the speed is 55 km per 1 hour, or just per hour. All right, so here's where you're going to get some stuff down into your notes. All right, so the first thing I want you to do is pause the video now and copy down the examples. All right, so you should have copied down the examples, and what we've got is the instruction is express each of the following as a simplified rate. Okay, so what they are both rates, but they're not simplified. Okay, so the first one we're looking at 12 students for 2 teachers. Right, so that's 12 for 2. Might write the 2 as the number 2. All right, so what we'll do is we'll simplify this, and that involves getting the second quantity, this one here, down to 1. So how would I do that? I would divide by 2. It's just like the example we did. All right, so 12 divided by 2 is 6. We're going to write the 4 and 1 here. So what is the rate? What we're going to say is it's 6 students per 1 teacher, or just 6 students per teacher. And that might be the rate of teachers you need to take on an excursion or something like that. Okay, this scenario here, imagine we've been to the butcher or gone to the nut shop or something like that, and the sign says $28 for 4 kilograms. And what we want to do is find out the simplified rate. Okay, and again, if you ever go to the butcher, you'll note that all the prices are quoted as per kilogram. All right, so we'll go $28 for 4. Okay, so we'll put our arrows in. We're going to divide that by not 2, by 4, because what we want to do is get the second quantity to 1. So we're going to divide that by 4 and divide this by 4, and that's $7 for 1. All right, so now let's write down our rate. So it's $7 per 1 kg, or $7 per kilogram. All right, so that's simplifying our rates. Now, the second thing you'll need to do in the bookwork is calculate what they call an average rate, right? So an average rate is calculated by dividing the total change in one quantity by the total change in the second quantity. What does that mean? All right, well, let's look at this case of Tom. So Tom was 120 centimeters tall when he turned 10 years old, and he was 185 centimeters tall when he turned 20 years old. So he's grown a fair bit, I would say. Well, I don't know, but yeah, it's grown anyway. So what we note, first of all, is we need to get the total change in one quantity and then the total change in the second quantity. So the first quantity is height. So we want the total change in height. So we can see the total change is 185, take away 120 is 65. So he's changed by a total of 65 centimeters. Now what we're going to do is get the total change in the second quantity. Well, that's just the change in time, which is going to be 20, take away 10. That's just 10 years. So the total change in time is 10 years, and the total change in height is 65 centimeters. So what we're going to do is formalize that into a rate. Say it's 65 centimeters in 10 years. All right. Now we want this now to be expressed as a simplified rate. All right. So what we're going to do is work out the per year growth rate, and that's going to be the average rate of growth of Tom. So we're going to divide this by 10 to get it down to 1. That's what we do. The second quantity is 1. And that's going to be 65 centimeters in 1 year. All right, so we formalize that in a statement. So we're going to say 6.5 centimeters growth per year. All right, so that should be your second example in your books with this definition included. All right, so once you've got that down into your books, what you're going to do is either start with this section here or this section here and adjust your questions accordingly. So again, if you finding them a little too easy or repetitive, flick over to here and do a few of those questions. So you be the person who judges which ones you want to do. All right, so I'll catch you guys next week. Good luck with that.